Here, let's set it down on the ground
Okay,
here.
all right.
Okay. And then
It's grounded.
not actually.
I'm a dad. The jokes come naturally.
Somebody's going to be coming by the studio later with something that's a little odd, and he wanted to know if it could be an antenna. So we're going to measure that in a little bit, but to measure something, you need a tool to measure it. And Dad, you brought something with you that I also bought one at your recommendation. What is it?
That's the NanoVNA.
Yeah, it looks like it's battery powered. What is it doing right now? I see like a dip on the screen.
Yeah, it's measuring SWR. So the low SWR at a frequency means that antenna is ready to transmit on that frequency pretty efficiently.
So, but what's the deal? I see like a little one there.
Yeah, the marker. So the cool thing about the test equipment in general, you can put markers on it. So the marker can tell you what frequency you're at, 939, and what the level is, how deep it is. It'll tell you how much of a notch you got there if you're interested in that.
And then this one, this says
Yeah, it says 915.
915 megahertz.
Yep.
But 930 is not 915.
939, not 15. And again, just disclaimer, every cable connector calibration matters when you're doing these kind of measurements. But this is a good ballpark, a good eye into what's actually going on. If that was saying 1.2 gigahertz, I'd be worried. But it's very close, and you'd be comfortable to say this antenna. Now, you guys in the ham radio, you know, you tweak these antennas, you clip them and cut them, and you watch, but you trust your equipment.
I noticed you brought some other gear with you too, like this. I'm kind of jealous of this box because I just spent some time buying some. I guess those are those F connectors, or N connectors.
They're adapters. So everything you do going in and out of the NanoVNA, you need an adapter because most of us don't in the field. You don't have connectors that are like that. What is that?
The SMA.
SMA.
I'm used to SMA for time and for Wi-Fi and things
We're used
like
to BNC and N connectors and PL259. So you just get adapters. And the thing about the adapter kit, I did not buy the multi-million-dollar super duper adapter kit, but whatever you buy as an adapter kit, once you test your connections through it and you like it, baby those things, keep them clean and keep them stored where they won't roll around and bang against things or get dirt or dust on them.
And then you brought this antenna. I have this one. This is like my fanciest antenna, I guess. But it probably
it moves,
this
it
looks.
telescopes.
Yeah, I know. It does multiple things. So wouldn't that be better than one that's like this, where it's just one? Whoops.
Yeah, this is like a baby ham antenna. I run at 450, 460 megahertz range. It's something you could use for receive, really. You wouldn't want to transmit through a cable like that on most of the equipment we have. So
you're saying that this one is 450. Can we see that on here?
Yeah.
Because that one says 915 and it's actually like 930.
Yeah.
But it's still within a pretty close range.
Yep. That's 875. So we're on the wrong setting. We want to go back down.
How do you change that?
Well, you would go something like, hit the menu, go to the center frequency. We're looking around 450. 450 megahertz, and so there you go. You can see in your dip here. So this biggest dip right there is going to be 458.
450.
So,
that's a little closer.
And again, that's about you're broad. You got a broad area here. And again, this guy, even if you take and start moving him, put your hand on him, you can see.
Yeah, so that's why, like, when you're watching TV in the old days and you like touch the antenna, it would change it.
Yes, exactly. So you want to do open air, wavelength clear measurements on these, and you guys that are lucky enough to have a little shack with some copper screening, you can do a lot of stuff to look at receive antennas. Transmit's a different world.
So you said where you put the antenna matters and the RF environment. We're actually close to some FM tower sites that have lots of different frequencies. So this is probably not the best place in the world, but the studio does have some sort of shielding through all the metal, the horizontal and vertical pieces. So I don't know. I know Wi-Fi has a hard time getting through from the front to the back of the studio.
Yeah.
But it's not like a Faraday cage.
Okay, so here's one. The antenna's on the floor back there, but you can see this one likes 498. So that 450, 460 range, it's missing that by a little bit. So, but it's got a nut there. You can actually unscrew that, trim it, and keep going until you get to the frequency you want.
That's fancy. Is this like a radio engineer's tool?
Yeah, that's those QC mounts or whatever they call Motorola mounts, people call them. You can get antennas of any length or any style and screw them on there. So you mount that. That's a mag mount, but you can mount them, cut a hole in your roof or whatever, and you can clamp those in, run that cable to your antenna receive area or your transmit area for that matter.
But now, would this be like for like 5 gigahertz now?
Yeah, that could be your 96 kilo, your Starlink transmission for the
You just need 1,000 of these.
8K video over Starlink. That's what that's for.
And then before I test this weird thing, and you're actually going to have to go, so you won't be here to test the weird thing.
Yeah,
But you have your own weird thing here that I was like, whoa, what is that? And then I realized like this could be a very useful tool. It's probably not like calibrated to insane specifications.
It's pretty close.
But
It's pretty good. You'd be surprised how accurate this is. I keep it safe in a place so it doesn't get hit with a lot of dirt, dust, laying open. But this is literally a testing kit where you can do your open short load calibration through calibration. You can do all of that, and once you do that, you should see some of these patterns which they put in here, and then also you've got some filtering that you can test. And we've done those tests, and you can, you set it up right and you follow it. So it's a good way to learn how to use your VNA too.
so without having to have a bunch of antennas.
Right, yeah.
And also, like I noticed when I was testing this one, I would be moving it or touching it, and the numbers are just going insane.
Crazy, yeah. You become part of the antenna. But you get onto these, when you clip on there, you'll see a very clean notch filter on that one. The roll off, you see, they all look pretty good when you get it right. That's a great way to learn. Buy one of these. Make sure you get the dual kit for it and take care of it. That's these guys right here. Take care of these connections. And we all hate those guys, but that happens to be what they use. We don't hate them.
UFL connectors.
We don't hate them, but we definitely don't love them.
So the thing that I'm going to be testing is a 3D printer bed as an antenna. What is your prediction about how that would perform?
Well, it'll do something. It's that's resistive material, so it's not the best. It's I don't know. I have no idea. I'm guessing you could receive some of those stations that are on the tower right across the street, but where it'll notch in, or I think that's unpredictable. That'll be interesting to see.
So I have Pooch from Repcord and so this is why I use a script. Okay, so I have Pooch from Repcord and Andrew from 3D Gloop in the studio, and you brought with you...
I brought a heat bed from the Prusa Core 1.
Okay.
And I had a weird idea, and it's probably nothing, but I was looking at some boards, and I noticed like antennas actually built into PCBs before.
And this looks like an antenna.
I guess. I mean, it looks like a heat bed to me, but I asked you, I said, do you think it could be an antenna? And you said, well, I've got the gear.
We have a way to measure this, so let's give it a try.
Time for science.
So this is called a NanoVNA, and it measures, it measures a lot of things, but we're going to use it to measure an antenna today.
Okay.
And this is a 915 megahertz mesh-tastic antenna.
Yeah.
And you can see that there's a dip now. This dip is measuring the SWR, which somebody can put in the comments exactly what that means, but it's basically like how good is the antenna at a specific frequency.
Okay.
And if we move the cursor around, we can see that this antenna seems to dip down the most around 930 megahertz.
They lied to us.
Well, they lied, but it's close. If we go up to 915, it's still below the baseline up there. So this is still a good antenna in that range.
Okay.
Really, like when you say a 6 gigahertz Wi-Fi or 5 gigahertz Wi-Fi, you're talking about the range, so 5 to 6 gigahertz.
Okay.
So if you get an antenna that's 5 gigahertz, it might do the best at 530 or 5.3 or something.
So close is good enough in, what is it, nuclear weapons, hand grenades, and now antennas as well.
Yeah.
Okay,
You don't have
close
to
enough.
be perfectly precise. But if you wanted a calibrated antenna for a specific frequency for transmission, you'd probably want to do better than just close.
Okay, so we can put that onto this and see if we actually get radio signals?
Yeah, and unfortunately, there's no way to just plug this in. So I can't just like do
That's not
anything
going to
like
do
that.
anything. Okay.
So I'm going to need to put an adapter on here.
Okay, how do we do that?
So we get out our soldering iron.
Ooh, solder.
We could do it that way just so I'm left-handed.
And I can't imagine this is going to have any impact on its radio receiving Would it?
It shouldn't, because this is a long trace, and it's not like we're dealing with gigahertz frequencies. We probably
I mean,
won't
if
be.
you had to predict anything, what frequency would this receive? do you
That looks
think?
in the megahertz, lower megahertz range, like 10, 20, 50, something like that. I don't know. I don't know exactly how this is constructed, but it looks like it's just one trace that's resistive that goes all the way through the board.
Right. It's a giant resistor to create heat.
Yeah, and it's
Right.
probably not a great receiver because it's not. It doesn't have 50 ohm impedance.
Well, let me ask you this: is putting a multimeter on it to see what kind of resistance is in the board of any value to what we're doing here?
It could be. So 2.9 ohms.
Okay.
2.9 ohms. That's not much resistance.
We may discover something amazing.
Yeah.
Who knows?
Probably not, but
Yeah.
we'll see. Okay, so
That's why I
side.
like to keep my expectations low.
Yep.
Okay, hold on. There we go.
Okay, so let's
Team soldering.
Oh, we're sticking on there. Okay, don't move that. Yeah. Okay.
Stay.
Okay. Now let me put a little bit extra on there. Okay, hold it still.
Trying.
Yeah.
I want to choke up on it a touch. All right.
Make sure you breathe in the fumes. That's part of the experience, you know.
I mean, that's how this whole thing came to me. It was a fever dream in the first place, induced by solder fumes.
Mm-hmm. That's how all the best things happen.
Right.
And that soaks up all the heat quickly.
I'm sorry, we didn't just flux the heck out of it. That's how I solder everything. I just flux the heck out of everything.
That's one way to do it. Where's
Right.
my? Oh, it's way over here. Got this guy.
Now you've done it. You've covered the LED. No, we still can see it. Okay.
Yeah, there you go.
Wow,
Good.
that actually feels pretty solid. Nicely done, sir.
Oh, thank you. I've done it once or twice before.
Yeah. That's an SMA. There's all kinds of different connectors.
Yeah,
there.
that's the fun of all this stuff is you have SMA and BNC and
And then you've
F
got
and
weird
N.
male and female variants of each.
Yeah, so I have kits of adapters everywhere. Like even this thing comes with a little male to male because they know how often you need these things.
I mean, this is more robust than some of the like USB adapter kits that I've seen over the years. Wow. Okay.
Okay, so now we're gonna see what happens here. We need
Okay.
to maybe let's put this here. Let's move this over here. Let's keep it away from stuff
Okay.
somewhat.
It actually did. It's got some dips though.
So that there, I mean, it could receive at let's see, 1 gigahertz. So you know,
Okay.
if you want to do GPS, this might be a good GPS antenna. But let's zoom
That's
out a little bit.
That's
I'll do
weird.
like 200 megahertz. And there's a few more dips here. Let's see if we go down to 250.
And are we looking for degree of dip from
Well,
your
now you're
trend line?
messing with it. You got to get your arm.
Oh,
out
that's
of
why my arm was in this. Well, I have a lot of arm hair too, so I think that does it. Okay.
there. You know, it's funny. Just moving this cable is also doing stuff. It's
was gonna
partly
say,
because of the solder job. It's not.
So the solder could be
Super
impacting it,
precise.
but like you are seeing some dip. Interesting. There's a more
Oh,
pronounced
you know
dip
what?
here.
That's because when I set my arm here.
Because you're the antenna.
Okay.
So you might have to search around for your most pronounced.
Yeah. So that's 130 megahertz.
Okay.
And let's go again to, we'll do like 50 megahertz. So we're starting to see a little more flatlining, but 41, I mean, the tough thing is I wonder if we plug this into like an FM receiver or an SDR, what we'd see on it. Oh, I need a longer cable. Let me grab one of those.
He knows exactly what bin it's in as well. It's the organization here is second to none, I have to say. It's very impressive.
How are you productive if you don't know where everything is?
You'd be surprised.
So we're going to plug this into an rtl-sdr V3.
Right.
They still make these, I think. They had a V4, which was better for certain cases, but they ran out of the chips for those, so now it's back to this, unfortunately. But let's we'll plug in this antenna, 098.1, play.
Ooh. Okay. We can get static.
There's a signal in there. Uh-oh.
No.
Now you've done it.
Uh-oh. What did I do? Did I short something? It's always more fun when you do it live. Whoops.
They make Dr. Pepper Tic Tacs? Did you see this? Look at that.
You gotta have Dr. Pepper everything. I
Oh,
have
man. I'm a
have a
pepper, you're a
sign.
pepper. There it
See?
is.
Dr. Pepper's my primary doctor.
My primary care physician.
Okay, this time let's see if
How did you pick 98.1, by the way? Was that where you
that's
saw that
Y98.
peak?
That was the first place I worked. First place I got a paycheck from.
Oh, wow.
So
98.5 was the radio station I listened to growing up. I was like, that's
Yeah.
really close. Okay.
yep.
Yeah, 98.5.
That's right
That's
in
where
the middle of
Carson
the dial.
Daly got his start. Fun fact.
Ah.
Oh no.
Nice. We've successfily. Oh wait, no, it's
You're
back.
crippling my computer.
I was like,
Okay. Oh, it's on AM mode. Let's go to FM. FM stereo.
oh, the static's better.
Yeah, it's stereo static now.
That's how I prefer my static.
Hardware AGC. Oh boy. Here, let's set it down on the ground
Okay,
here.
all right.
Okay. And then
It's grounded.
that
I'm a dad. Is that the jokes come naturally?
might be a liar.
Science is off.
I'm glad that we did this, so we at least have a control.
Maybe my SDR is not happy. What is going on? Wait, this should be, but that shouldn't be a problem.
Gain, receiver options.
8. Oh, here we go. I think I must have been testing something funny.
There we go.
This is an old song.
Yeah, it is. This is like 90s. What have we learned? The antenna is a good antenna.
We've learned that I am way off on this. Okay, let's try.
So wait, did we not have something set properly?
Yeah, the software was off. I had.
Okay, we can cut that part.
Yeah, we'll just cut it.
We panicked too soon, perhaps. Who knows? It's still going to be terrible.
It might work though. That's the key. A little bit.
Okay.
I was expecting it to work a little bit because we're like less than a mile from the tower.
It's a completely
the
impractical.
amount of energy.
It does work.
Oh no way!
It does work.
I mean, it sounds
You're better than your antenna
That's
even.
something.
You hear it? It slaps now. Oh, now it's
98, St. Louis.
Is it now? Does it have anything to do with the fact that I'm touching it?
Let's set it
grounded.
down.
It's
Yeah.
Okay, now it's grounded. It's a
Okay.
little fuzzy. What if I?
So to get not demonetized, I'm going to turn that down for a second. So another thing we need to check is this wire being in antenna?
Well, how much is the wire? Yeah, exactly.
Okay.
So how do we
Okay.
determine that?
Okay,
just
how good
take-
is my finger?
Not good.
I bet if I poked my finger into there and got it inside my body, it'd be a little better. But yeah, okay.
a Tic Tac
so the
on
wire's not doing it.
Wait, is this? No, that's not the right kind. So it's not just the wire.
So next
So it is
question,
having an antenna effect.
Some sort of
So next question is this the antenna right here? If I block that part. No, it's working. Okay, so it's an antenna.
It's viable.
If you were in an emergency situation and you had no other way to receive the radio,
Take apart your 3D printer.
and get your computer running with an SDR
Right.
and get out your soldering
Make
iron.
sure you solder it well.
Okay. Well,
Honestly, that surprises me. I wasn't expecting it to do much of anything.
yeah. Let's try another station. Tune
Okay.
into 101.1.
It
Oh,
only.
okay. That
Oh.
station is more than a couple miles away.
Okay.
So it can receive if you're within a mile of the tower.
Okay.
That's
So for any kind of distance, it's
yeah.
still
you
a
wouldn't,
terrible.
You wouldn't want to do DXing, like ham radio DXing with a printer bed.
Okay. But again, we said you saw a spike for FM, but it could be better in other frequencies for other applications. We don't know. We would
could
have to have different equipment to test
Yeah.
that.
I mean, I think that you're going to have to go home and be testing this for weeks now.
No, I won't be doing that. Nobody knows really how any of this works.
Well,
Just a little solder and some wire, and you're done.
yeah. Well, thanks for coming down to St. Louis.
This was a lot of fun, man. You have a beautiful space here,
Thanks.
and it's always fun to see how creators do their thing.
Yeah.
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 Thank you.
Yeah. Thank you.